Hello everyone, my name is Sneha Agarwal and my topic for the assignment is tree. Okay, let us start with the basic definition of tree form. We all know about arrays, linked lists, queues. These are the linear data structure because they form in a line. But what tree is? Tree is something non-linear data structure which forms a hierarchical pattern, or we can say the collection of nodes such that each node of the tree stores a value. Okay, so we can define tree as a non-linear data structure and forming an hierarchical pattern is something and called tree. Okay, we can understand from this data structure, this diagram here, and all the basic terminology of the trees we will understand here. Okay, let us start with the main. From where the tree starts is called root. The main node from where that we start a tree having a value is termed as root. We can here in this diagram we can see a is the root because it is a main node from where the tree is getting started. Okay, the further we have further term we will use in this tree is children. A is divided into two nodes, that is B and C. So we can say B and C are the children of A. Or further, on further going, we can say that D and E are children of B, or G and F here in on level two. On level two, C in the diagram. On level two, we can say that G and F are the children of C, are children of C, and and it goes on. And if we talk about parent, so we can say that B is the parent of D and E. Okay. Or the another term we get here is siblings. So if a node has two siblings, okay, if a node has two nodes, then those are siblings. If a common node having two nodes or having two nodes or more than two nodes are termed as siblings. मतलब जिन अगर एक पेरेंट है उनके मतलब दो चिल्ड्रन हैं तो वो जो दो चिल्ड्रन होंगे वो आपस में सिबलिंग्स कहलाएंगे. Here in this diagram we can say that D and E are siblings, or we can say G and F are siblings. Okay, or we can say on level 4 we can see in the diagram on level 4 K and L are siblings like this. Okay, next term we got is subtree. Subtree is something that another tree formed under the tree. So if we are standing on node B, then uh, B, D, and E is a subtree. Okay, subtree is a tree formed under another tree. Okay, uh, and then we have leaf. We see in the biological tree outside. You can see the tree outside. You have seen several parts. First, the tree has roots, then stems and branches, and then leaf. Leaf is the last point of the leaf is the last element of that tree. Okay, so here also leaf is the last node of this tree data structure. The last node of the tree data structure is termed as leaf, node which does not have any children. Okay, we can say that the node which does not have any children is termed as leaf. And another term we will see here is ancestors. Ancestors are like you have parents and grandparents and grandparents. So these are their so all these are your ancestors. Now similarly here we can see that if we have H, then D is the parent of H, and B is sub D and D is grandparent of H. So here D, B, and A are the ancestors of H, or we can say like H, D, B are the ancestors of K. Okay, ancestors are something from which the particular ancestors are the nodes in between the node we are talking about and the root. Okay, so this is all about the basic terms of the basic terms of the tree terminology. Okay, now we have trees. We have different types of trees. Okay, so for here we need to understand about here we will study about binary tree, because here we have main focus on binary trees. Okay. What is binary tree? Binary we understand by the term binary is 0 or 1. We deal with 0 and 1 in binary term. Okay. So a binary is something having two nodes. At this in binary tree, parent node can have either 0, 1 or 2 nodes, not more than 2 nodes. It in binary tree, a node or the root or parent or something can have at max two nodes, not more than two nodes. Okay, that is what we call a binary tree. Okay, so here we can also wait a second. In this diagram, we can also see that like A have two nodes B and C. Further, B have two nodes only, D and E. Further, C has two nodes G and F, and further F has only single node. That can be happen, but we cannot have more than two nodes for a particular parent node. Okay, that means a parent can have maximum of two children, not more than two children. Okay, that is all about binary tree. Types of binary trees. We have five types of binary trees. Okay, first is full binary tree. In full binary tree, the node has either 0 or 2 children. It will have either 0 or 2 children, right? That is that the parent will have either 2 or no children. Okay. So here we can see in this diagram, like this is the root node and this has 2 children. This is the root, this is the parent node and this has 2 children, and this is the leaf. Okay, this is the leaf and which has no children. Okay, so this is the full binary tree. And if and the second, okay, the second type is complete binary tree. Complete binary tree, the binary tree which in which all levels are completely filled except the last level. Complete binary tree is something which have all levels filled except the last level. Okay, the last level has all nodes in left as fast in left as possible. If we see in this, like this is the complete binary tree. All levels are completely filled. All levels are completely filled. That means all have two children. Okay, and if in this we can see like all levels are completely filled, and in the last and in the last and this is the if this is the last sorry, if this is the leaf that is in the left, on the extreme left, we don't have its right children, we have only its left children. So this is the complete binary tree. And the third type of binary tree is perfect binary tree. In perfect binary tree, all leaf nodes are at same level. If we have leaf nodes or all at same level, then it is termed as perfect binary tree. Here we can see that all leaves are at same level. All leaf are at same level. Okay, so and here we can also assume the height of the perfect binary tree by having the formula of, sorry, we can assume the node in the perfect tree by having uh, known its height, that is 2h minus 1, where h is the height of the binary tree and 2h minus 1 is the number of nodes in the perfect binary tree. Okay, okay, then we come on the fourth type of the binary tree, that is balanced binary tree. A binary tree is said to be balanced. Okay, in this binary tree, if height of tree at max will be of log n, at max log n, okay, where n is the number of nodes. A binary tree which has height at max of log n, where n is the number of nodes, that binary tree is termed as balanced binary tree. Suppose if there are eight number of nodes, then if there are eight number of nodes, then the height of the binary tree will be log 2 log base 2 8, which will be equal to 3, which will be equal to 3. That means the height of the binary tree with 8 number of nodes will be 3. That is called a binary tree. That it at max the binary tree can have three levels. Okay, last level we come to is the degenerate binary tree. Degenerate binary tree is something in which every node has a single children. Every node has a single children. See, this is a root having single children, having single children, having single children. This is termed as the degenerate binary tree. So we have understood five types of binary trees. First is full binary tree, then complete binary tree, then perfect binary tree, and balanced binary tree, and last is degenerate tree. Okay, now we will represent a binary tree. Okay, so first of all, we understand array representation of binary trees. See, we have some difficulty in representing binary trees in arrays. As in array, we have to fix the size, and further it will be very difficult to increase the size of the array. So, okay, then also we will understand how to represent binary trees in form of array. Suppose we need to create a binary tree having 7 nodes. Okay, so we have to take the array of size 7, and the corresponding elements will go like this on 0, 1, 2, 3, 4, and here 5 and 6. Okay, So for on 0th index there will be 0, on first index there will be 11, and it goes like this. Suppose we have an binary tree which which is not perfect binary tree. Okay, so which is not a perfect binary tree. Suppose there's like this one. Okay, this binary tree. If we talk about this binary tree, we will show it like this. Like it is 0, 7 on 7 is 0, 1, 2, 3, 4, 5, 6, 7, and on 8th index we 7, this 7 has only one children now. So on 8th index we will just show it as null, null. uh, if we if a parent has one or one only one node, so then the second node will be represented as null. And if it is not on the if the leaf or if the leaf of all the nodes are not on the same level, then then the parent which doesn't have children, then also those children will be shown as null. Okay, so we can see here, and the array will be represented like this. In C we can store the elements as null, so it will be easy in C. uh, See here, like 0, 1, 2, 3, and on 8th, 9th, and 11th, which does not have any node or any children, we will store it like null. Okay, this is all about array representation of binary trees. Now we will see about linked representation of binary. Okay, see, in linked list, what we store is the data, is a value, and the data of the previous and the data of the further. We can store binary trees in double linked list. Okay, we can't store it in a single linked list as it has two nodes now. So we can't represent in a single linked list. Single linked list represent only the data uh, and the address of the previous node. Okay, so we will represent it as a double linked list. Okay, so okay, we will start from here. See, this two has two children now. So left one has one and the right one has value 4. So two having two children, this one has 4 and this one has left one has 1 and right one has 4. So it will be represented like this, like 2 and the left box of this 2 will store the address of 1, and the right box of this 2 will store the address of 4. Similarly, this one will store left one will store the address of 11, and the right one will store the address of this 12. The left right one will store the address of this 12. Similarly here, see, this 4 doesn't have any node on its left, so we will store it as null. So this is the linked list representation of array. Sorry, linked list representation of binary. Sorry, slip of tongue here. Now this is the structure of node. This is the structure of node. See it properly. Here we have the date value of the tree. In left column we will store the address of the left children of that node, and in right column we will store the address of the right children of that node. Okay, this is the structure we will study about in linked representation of binary. Here's the structure. Okay, this is all about my assignment. Thank you.